We would like to introduce our work, Multitask Reinforcement Learning and Continuous Control with Successor Feature-Based Concurrent Composition. For a reinforcement learning agent, the objective is to solve a task, represented as W, by training its policy. Through interactions with the environment, the policy improves performance until it becomes the optimal policy. On the other hand, in our multitask reinforcement learning, an agent can possess a certain amount of subtask policies or primitives. Its goal is to recover the true policy of each task by composing these primitives. Therefore, it is only required to train on a set of primitive tasks and then transfer to any arbitrary task, which significantly improves the sample efficiency. Since composition can happen in real time, our multitask agent can achieve online composition and be trained end-to-end like any single task agent. In this work, we introduce many composition methods and explain the theory behind these methods. We evaluate the multitask composition agents in the point masses and pointer environments. In point mass, we train the X-control primitive only learns to minimize the error in the X-axis, and the Y-control primitive only learns to minimize the error in the Y-axis. Our composition agent can then compose these primitive distributions to solve a XY control task. Similarly, in pointer, we train one primitive to solve position control and the other primitive to solve angle control. Composing them allows us to solve a joint position angle control task. Lastly, we evaluate the transfer performance of the compositional agents in more complex task settings. Our experiment showed that the transfer performance increases over time in new unseen tasks that are not generalizable for the single task agent, SAC. The paper includes many other experiments demonstrating how transfer happens and some ablation studies on increasing transfer performance. Thank you for watching. We also openly provide the code in the link below.